Hello class, today we are going to learn what lateral surface area is, and then we're going to see the difference between total surface area versus lateral surface area, specifically for a cylinder. So let's draw our cylinder. By the way, you're just watching the video, you're not, you can write these notes if you want, but mainly I just want you to pay attention. Okay. So these are somewhat badly drawn, but you get the point. For total surface area, you're finding the area of the whole cylinder. So that includes the middle part, the top part, and the bottom part. For lateral surface area, what lateral surface area is the surface area only of the sides of that shape. So the sides of the cylinder is just this middle part. It does not include the top and the bottom. Lateral surface area for any shape is only going to be the sides without the top and the bottom. So for example, if you are sitting in a box, then the sides of the box would be the lateral surface area. The top and the bottom would not be included. Another example would be if you're a painter and you're repainting your room, you would find the lateral surface area of your room because you would only want to paint the walls of your room. You don't want to paint the ceiling and the floor. The ceiling and the floor are the top and the bottom, of course, which are not included in lateral surface area. Okay. Now let's, I'm going to draw the net for a cylinder. I'm always going to draw two pieces, by the way, just so I can compare and contrast the two things. So the net is, again, as a reminder, if I were to flatten this shape out, what it would look like. For example, if you were to flatten a cardboard box out, what you get is the net of that box. So if you were to flatten out this cylinder, it's going to look like this. It's going to be a circle. It's actually going to be two circles and a rectangle. You can kind of imagine it. If you were like to fold it and roll it up, it's going to be looking like a cylinder. I'm going to get a better camera soon so I don't have to hold my phone and write at the same time. That's what's making it difficult, but bear with me for now. So here we have the net. Again, here I'll write the word net. I'll write nets because there's two nets. So you remember what that is because you're going to see that word quite a lot. Okay, so again, we know what lateral surface area now is. It's the area of only the sides of the shape, right? And total surface area would be the sides, top, and bottom. So looking at the nets of the cylinder, if I'm looking at the net and trying to find the lateral surface area, I only have to find the area of that middle rectangle. So if I can find the area of this middle rectangle, I have found the lateral surface area for the cylinder. We know that the area for a rectangle is just this side times this side. I'm going to call this side height. And I'll call this side width. The thing is, we usually don't know what the width is. Usually the problem will give you what the height is, but they won't give you the width. But if you flatten out this circle, imagine this circle is like a shoestring, right? And I put it in a circle, but then I made it straight, right? If I straighten the shoestring out, it would lie exactly on the side of this rectangle, and it'd be this exact length. So if I can find the distance around this circle, which is also known as the circumference, then I know what this width is. The formula for circumference is 2r pi. And remember, r is the radius. So all I have to do to find the area of this rectangle is do this side times this side. We know this side is height. We know this side is width, and the width is actually going to be the circumference, which is 2r pi. Putting all that information together, we know that the area for this rectangle is going to be 2r pi times h, because it's width times height. Width is 2r pi, so therefore width times height is 2r pi times height. And that's how I get this. I'm going to write down the lateral surface area formula for you now. Lateral surface area, which again is the area of just the sides of any shape. No top, no bottom. Formula. We got 2r pi h. Remember, when there's no symbol in between things, that just automatically means multiplication. And also, please don't get confused when you see 2r pi. That's the circumference. It's not the area of the circle. Area is how much space is inside. Circumference is the distance around the circle. Okay, now let's compare this lateral surface area formula with the total surface area formula. So total surface area is going to be the area of the two circles and the middle part. Let's find the area of the two circles first. We know that area of one circle is pi r squared. Pi r squared. So if I add these two circles up, I get 2 pi r squared. One circle is pi r squared, so two circles is 2 pi r squared. Now, I also had to add this part. So what is this part? We actually know what this part is from the lateral surface area. We already found that rectangle. It's 2r pi h. So I could just put that in. 2r pi h. And there you have it. That is the total surface area formula, which I will rewrite for you just for the sake of symmetry. Symmetry means that this side and this side has matching spaces. So we got total surface area formula, which is 2 pi r squared plus 2r pi h. Okay, so last note is that when you look at this formula, I want you to be able to understand that this part of the formula right there, that corresponds with that rectangle. That's where I got that from, that rectangle. And then I got the 2 pi r squared from the two circles. Right? Because one circle is pi r squared, so two circles is 2 pi r squared. Again, this part of the formula is from the rectangle, and this part of the formula is from the two circles that we have. And there you have it. Here are the two formulas. This is the new one that you have learned today. Again, as a recap, lateral surface area is the area of just the sides of the shape. Excuse me, I'm sorry. Is the area of the sides of the shape. As you can see, the formula for the total surface area incorporates this, but it also adds on the two circles. There you have it.